Have you ever wondered how modern wind turbines are built? Wonder no more. In this video, we're exploring how Blattner Energy and Pattern are building SunZia, America's largest ever renewable energy project. This $11 billion endeavor has two parts. First is power generation. SunZia Wind, the largest wind energy project in the Western Hemisphere, will eventually have 916 wind turbines provided by Vestas and GE Vernova. While in this video we only see some of the 674 GE Vernova turbines on site, there's an additional 242 Vestas turbines on this project as well. Combined, they'll produce over 3,500 megawatts of power, on par with America's biggest power plants.
Second is the 552-mile transmission line, which will carry the power to the 3 million end users. We covered this with Quanta Services in another video linked in the description. And spoiler alert, they used some sweet military helicopters to make it happen. But as mentioned, today's video is all about the wind turbines with Blattner Energy. Before we dive into the details, here are the basic steps to building these enormous structures. First, the owner, Pattern Energy, oversaw years of research and advanced modeling, which helped determine the location of each wind turbine to maximize the energy output given the average wind speeds. Then, for construction, crews dig each foundation at the predetermined locations. Once they form the steel and pour the concrete for each, assembly crews stack 3 shaft sections for each GE Vernova turbine and 4 sections for each Vestas turbine, then place the nacelle and the 3 blades. And to connect it all, crews run collection lines underground between each tower, which end up at a single point for transmission. Now that we've got the basics, let's dive deeper into step 1, foundations. The force pushing against these towers will be immense, so they must have a solid footing. Excavation crews dig a hole roughly 12 feet deep and 100 feet in diameter, yielding a few thousand yards of earth, which they stockpiled nearby. Steel crews take over, forming the skeleton of the enormous spread footings for each turbine, measuring up to 70 feet in diameter. The entire project will require 450,000 tons of reinforcing steel. Concrete crews follow the rebar, with a mobile batch plant producing over 400 cubic yards of concrete for each GE Vernova base and over 600 cubic yards of concrete for each Vestas base. Crews can finish each base in hours using mixer trucks for material transport and telebelt trucks for placement. Let's jump to our first visit for a closer look at the foundation work. In total, SunZia will require 530,000 yards of concrete. Once earthwork crews come back to backfill the base, all that's left is the pedestal with bolts for the eventual tower and conduit into the ground for the future cables. Once earth moving for each site is complete, crews will finally replant native vegetation to match the surrounding landscape. Now it's time to go vertical. As mentioned, SunZia has 2 turbine vendors, Vestas and GE Vernova, who've both been kind enough to be part of the video.
The base mid-crews are first up to perform two functions. First, they assemble the nacelle, which I'll explain shortly. Due to transport constraints, it arrives in several pieces, with assembly happening at each turbine site. Second, they build the first two sections of the tower, called the base and the mid-sections. Blattner has 11 crews between the north and south sections of the project, working well ahead of the top-out crews, so the landscape features many partially completed towers. This crew here is about to start assembling this wind turbine. And I know what you're gonna say. You're gonna say, this guy doesn't know how to say turbine, turbine, turbine. It's turbine, I know, just give me a break. Right there, they are waiting for the Big Daddy crane to get here though. While they're waiting for the crane to get here and get positioned to start assembling the shaft, they are working on the nacelle. That green bit there, turquoise bit, is the generator. That is what makes the power. And before we get to the assembly, let's go back to the studio and review how wind turbines work. The wind blows, which the blades capture efficiently. This spins the rotor connected to the drive shaft and gearbox. The gearbox increases the shaft's speed and spins the generator, transforming the mechanical energy into electricity through electromagnetic induction. This is no different from almost every other form of power. The power then flows down the tower to the brain, which sits at the bottom, helping to smooth out the power before sending it via collections to transmission. It's worth noting that modern turbines are advanced, able to collect enormous amounts of data and adjust based on weather conditions. Now let's get back to site for the erection. When you have almost 1,000 of these to assemble, logistics is everything. So there are teams that have been transporting these bases, the blades, everything that's necessary for each turbine across the United States. A lot of this is coming from Florida, Texas, all over. And then they're staging all of the pieces at the base of each turbine. So everything is here. It's basically a giant erector set. They have lowered the generator and the gearbox into the nacelle there. Then they've put the lid on. They're getting it situated as we speak. They will take off the rigging, and then this crane is done over here. They're gonna walk this crane over to the other side, and we're gonna get started with the shafts.
Watch your hands!
Watch your hands!
Watch your feet!
How's that looking?
Blattner uses two cranes to lift each tower section. Here, they're using a Manitowoc MLC 165 and MLC 300. The transport crews position the base sections strategically, allowing the cranes to sit on their respective pads during the work. Both cranes lift the first section off the ground in tandem. Then the bigger crane begins to lift further while the smaller crane stays in position. Thanks to a special bracket, the section rotates off the ground as the big crane continues to take the weight, protecting the special structure from damage. Once entirely vertical, the big crane has all the weight and can begin positioning the section.
How many holes?
Yeah, you look at about 6, 7 holes.
Man, I don't have to go no left or right. Come on, guys.
All right, it's off over here.
Easy.
Yeah, they're gonna stop. Okay.
Okay, right there, boy. Now pull out these safeties. Pull out these safeties before I come down. Y'all need some new safeties in that landing. Watch your hands, watch your feet. Be careful with your hands, feet, toes, feet, whatever.
After the crew positioned the section onto the base, it was time to torque the bolts. Next was the midsection. For the midsection, the cranes on the ground repeat the same dance, and then the big crane lifts it to where Wyatt and the tower crew were. From there, they position and torque the sections internally from the work platform within the previous tower sections.
All right, overhead. Watch overhead load.
This is when the mid-base crews take off to the next site, allowing the top-out crews to handle the rest. But we had a problem. It's windy. Yep. Ironically, crews can't assemble the remainder of the wind turbine here while it's windy. But we don't give up. After not one, but 2 attempts for more favorable wind conditions, we finally lucked out this May. Starting with a 1.5-hour drive into the New Mexico desert, we arrived at the Zone 2 laydown yard and got acquainted with the day's work. Fortunately, multiple crews were working, so we had a few options. Before the blades go on, let's visit with a crew about to place the final shaft section, which is only one site over from the one we captured previously.
It is finally time for top out. The very top of the wind turbine, we've placed the base and mid sections, but there's 3 sections total. This is the final top section before the nacelle and the blades can go on. So we just saw the crew with the smaller crane, bigger crane, lift that section up with no contact with the ground whatsoever, nice and safe, just like the previous 2 sections. And then you're probably wondering, what the heck was the deal with the ring around the rosy and putting those black things around that top section? Well, that helps with wind, with sway, preventing that sway. So they don't put top out until they can get the whole turbine together, but there's still a period of time between this and the rest of the turbine to ensure it's all balanced. So if you didn't put those black pieces of pipe along the outside of it, you could have wind pushing that tower around since it's getting much taller. But with that, it disturbs the wind a little bit, preventing that tower from swaying as much, keeping everything nice and safe. Before they can fly this, they're attaching these bags of tools, bolts, etc. So these will be what the guys up tower, they're already up there, need to attach this top section to the mid section, and then they will fly more material once they get to the nacelle.
We heard blades were going up at another site, so we scurried away to catch them before seeing this crew put the nacelle on. However, it's a similar process, with the crew starting with a completed and tested nacelle thanks to the base and mid crew. After the big crane has nearly reached the final position, a crew of 3 carefully guides it home over the radio as the crane operator has limited visibility. To secure it, they torque all the bolts to the tower, and now we're ready for blades.
All right, this is our 4th time out here. We saw foundations the first time, tried to see top out the second time, too windy, tried to see top out the third time, too windy. 4th time is the charm. That's top out right there. That's what we've been after for months now, seeing blades go on top of the turbine and make it a full wind turbine. Now that we're in top out mode, we are using the big crane. This is a Manitowoc 650, and this would be the point of the video in which I would pull out my phone and would read some statistics, but I have no cell service, so let's go to VoiceOver Aaron to give you some of the stats on that big boy.
Blattner's using an MLC 650, which is Manitowoc's second largest crawler crane. The MLC 650 boasts a lift capacity of 650 metric tons with a maximum working height of over 340 feet. And fun fact, that's around the same weight of 2 Cat 6015s sitting on the back of this thing in counterweight alone.
Thanks, VoiceOver Aaron. When we got here, they had the first blade on. They were finishing that up. You saw the blade was parallel to the ground. Now it is perpendicular. That's because once they got the blade on, they're able to slowly rotate the hub to get that blade perpendicular so that they can put the next blade on parallel with the ground. And then once that second blade's on, they rotate it again for the third blade.
Now that the tool is in place, it's time to prepare for the lift. Blattner crews attach ropes on the blade. Thanks to a simple pulley system, the ground crew can assist with lining the blade up with the hub. This system makes the lift more effective and safer and prevents damage to the blade. With everything attached and the wind speeds okay, it's time for the lift. Once the blade is in place, the crew's up tower torque bolts, allowing the tower to take the full weight of each blade. And just like that, we have ourselves a finished wind turbine. Rinse and repeat over 900 times over the next few years, and there's power for 3 million people. After the mechanical and electrical testing and the final grid connection and power system integration, SunZia Wind is expected to come online in 2026. And if you're interested in a career with Blattner Energy, they have tons of job opportunities at projects like this across the United States. You can apply now at blattnercompany.com/careers.
And that is everything you need to know about building wind turbines. Thank you so much to Blattner Energy and Pattern for having us out. I hope you enjoyed this video as much as we did, and we'll see you on the next one. Stay dirty, everybody.